In this video, we will look at graphs of exponential functions. You will find this on page 413 in the Namibian AS-Level Mathematics textbook, y equals mx+c to success. Graphs of exponential and logarithmic functions. We will also look at that. But first we start with graphs of exponential functions. We learned to solve exponential equations and natural exponential equations in a previous section and in the previous videos. In this section, we will study the graphs of the exponential function y equals a to the power of x, where a is a positive constant and a cannot be 1. If a is 1, the graph will just be a horizontal line. We will also study the graphs of the natural exponential function y equals e to the power of x. Now, you can go through this investigation. You can look at the solution in the teacher's guide. You can click on this QR and you will see a video on this investigation. It's very good to see the different graphs and to see the pictures. I'm just going to look at the summary. Okay. And I'm going to make it a bit bigger so that you see better. So this is the summary out of the investigation. So the investigation reveals the following properties of exponential graphs. Very important. Memorize the basic shapes. It will help you when you sketch the graph. So if you already have a picture in your mind. Okay, so the first one, if it's y or hx equals 10 to the power of x, can you see? Then it's very close, but it's always a curve going like this. If it's y to the power of 2x, it's going wider. Can you see? It's there. And if you see that it's even becoming smaller, it's y equals 1.2. It's even going wider. So the bigger that base, the closer it is to the y-axis. Now, don't forget that the value of e is actually 2.7. It's an irrational to the power of x. And that's why it's a bit closer to the y-axis than y equals 2 to the power of x. Okay, so this is very important. Maybe we can so the base is always positive. Can you see? So it's bigger actually than 1. So let's first look. The graphs of the intersects the y-axis all at this point here is 0 and 1. Okay. The graph does not intersect the x-axis. So it's striving, but it's never crossing the x-axis, although they get closer and closer to the x. So the x-axis is the horizontal asymptote. That's what you call it if you're going closer and closer to that. Okay. Let's look at, so this was when the value of a was bigger than 0. It was positive. Do you see? All positive. Base, look at the base, all positive. But now, look when the base is between 0 and 1. Okay, so this was, this is going to be a fraction in this case. So if you're going to say, now in this case, it's going to be 10 to the power of negative x. But actually, don't forget that it's 1 over 10 to the power of x. Okay, this is e to the power of negative x. This is 2 to the power of negative x. And this is 1.22. So it's actually compared to this one. Now look at the shape. Where this one was going to this side, this one is going to the other side. So now, so this will be an increasing and this will be the decreasing to this side. So it's actually also crossing there at 0 and 1. Okay, so let's just go through a few points. 2 to the power negative is the same. Okay, this is very, very important. So this is where the fraction is coming in. So if it's 2 to the power of negative x, it's this. So this one was, what I wrote there was, the x was a little bit upper. So let's just make the x must just sit there. Okay, so this one was 1 over e, and it's to the power of x. Do you see the fractions between that values? This was as I said there, 1 over 2 to the power of x. Okay. The graph do not intersect the x-axis, although they get very close to the x-axis. The x-axis is a horizontal asymptote. Right, let's go on. Put it up, so that we can also see the example. The graph of fx equals a to the power x is the reflection of the graph this in the y-axis. Very, very important conclusion, which I didn't mention already. Can you see that this one reflects, is this one a reflection in the y-axis? Okay. The two graphs are symmetrical about the y-axis. So it's meaning that this one reflects, so you can, this y-axis is the line of symmetry. Okay, let's look at the example. Sketch the graphs y equals e to the power x and y equals 5 minus x on the same set of axes. Okay, state the number of solutions to the equation. Before we come to this, look how we sketch. Now, it's very good if you already know. You already know. It's almost like you can, I'm just going to quickly make for you a picture here. It's almost, but I'm going to do it a bit more accurate than this picture. But it's almost that you know, okay, I know that one is like this. I know, like this. And I know it cuts in there at 0 and 1. But it's just how close it will be there. And this is why I make a table. And then to draw this one, I know it's a negative, and I can find where it cuts the y-axis and where it cuts the x-axis. Okay. But for this curve, to see if you must draw it like this or closer to the y-axis or wider to the y-axis, make a table. Start with -1 and just press it on in your calculator. So you're just going to say E. Okay, so press Shift E and -1 and approximate it to 1 decimal, 0.4. And then e to the power 0 is 1. And then just Shift E above the ln, 1 equals, and it's 2.7. And Shift E2 and it's 7.4. And if you do it then like this, then it will be easier for you to have a more accurate, because you must come to the solutions. Now, do you see basically, it was that they basically solved this simultaneously. So it was like, say this was e to the power of x, and this was 5 minus x. And then this was equation 1, and this was equation 2. And then it's like substitute that equation 1 into 2. It's basically that I basically just, and this is what I did, I just substituted there. Then it's e to the power x equals 5 minus x. And I want you to go on and then take everything to one side. So e to the power x plus x minus 5, and that is equal to 0. And this is exactly what is standing there. And then how many solutions? How many times is it cutting each other? It's only one. So only one point of intersection of the two graphs. So it's only having one solution. Okay, I want you to stop the video and I just want you to do number 1. Again, you can continue the video as soon as you are finished. Okay, I think I'm first going to do the table, and then after the table, I will do the sketch. Okay, let's start with number 1. On the same, sketch the two graphs. Now, what is my two graphs? So it's y is equal to a half to the power of x. This is the one. So let's start with this one, and then we can do where this one cuts the x and the y axis. Okay, so I'm going to just make it in another color, and y equals 1 minus x. Okay, let's start with the yellow. If I make a table, now I must have a picture in my mind. This is what I said. If you just memorize the basic shapes, then it's easy. So if you have the picture in your mind, okay. if I'm this half, so I already have this picture in my mind, and I can show you here. Okay, say this is my sketch. So I have the picture in my mind that I know this is not going to this side, it will be something like this. But I can, because it's going more to this side, so okay, let's just start here. This is x, this is y. Because it's going more to that side, let's take -2. Okay, let's take -1. Let's take 0 and 1. I think that's enough. Okay, now I'm just going to press on my calculator. I substitute the value of x there. So I can press, it's 0.5 to the power -2. I just want to see, and this is giving me 4. I just want, sometimes 0.5 to the power, I just want to see a bracket, if it's making a difference. I put a bracket, the negative, it's also 4, it's fine. Okay, so I make the 0.5. Otherwise, you have to make, you can also, I'm going to press it, you can put bracket 1 divide 2, close the bracket, to the power -2, and that will also give you 4, but 0.5 will work. So 0.5 to the power -1, and that is 2. And then 0.5, and you already know that, to the power 0. Anything to the power of 0 is 1. And then 0.5 to the power, and you already know that, 1 is just 0.5. And for this one, I will prefer that it's a straight line. It's a straight line. So let's make it the x-intercept. And you make y 0. So it's 0 equals 1 minus x, so x is equal to 1. And then the y-intercept, you make x 0. So if I make x 0, then it's 1 minus 0, and that's just 1. Okay, so this is actually very nice. It's cutting at 1 and 1. It's actually x plus y. Just for the interesting, always if you have an equation, which in this case y plus x is 1. In the previous one, can I just show you? I just have to go back to the previous one. The previous one was actually y plus x equals 5. And then it's very easy. Then it will cut at 5 and 5. Whereby the next one, the next will cut at 1 and 1. Okay, but let's make a grid. Let's get our grid. Where is the grid? Grid. Okay. Do it with a ruler, make 1 centimeter. You don't have to do it on graph paper. Okay, but with a ruler, now I might just take another color here because let's make it green. Okay, so that otherwise you're going to struggle to see. Otherwise, it's not going to give you to see how many times it cut. Right. Okay, say for example, it's like this. And now I see y is up to 4, so I can do it like this. I'm going to mark it quickly. So this is going to be 1, 2, 3, 4. This is going to be -1, -2, but it's not necessary. This, I think it's going to be better if we make this one 2 units, just to see the sketch better. So make this -1, make this -2. As long as this scale is the same, this one can be having his own scale. But if you make this 2 units, then this must also be 2 units. Okay. Again, it's not necessary up to there. Okay, now I'm going to plot. Now first I'm going to plot this one. So -2 and 4, there is it. And then -1 and 2. And remember your sketch. Remember, it's actually not going up, it's going a little bit down out there. And then 0 and 1. And then 1 and 0.5. Okay. But it's on the y-axis 0.5, so it's going to be there. You could have even go, if you want, if you see, okay, I don't have enough, do it. You're not fixed, it's your own sketch. So then say, okay, I want 2 also. Okay, so 0.5 to the power 2, and that is going to give you now 0.25. So, okay, sorry that this one was just, it was not plotted correctly there. And I just correct it. Did you see that? It was at 1 and 0.5. Do you see? There's 0.5. And then at 2, it's even going closer. And now you can make your sketch. Okay, something like that. And this is my sketch is y is equal to a half to the power of x. Now I'm going to make my blue one. I just need 2 points for my blue one. This one should have just go. Okay. And then I just take a straight line, take a ruler. And now I just want to see, okay. I must actually extend. Okay, what I'm going to do, it's a bit more difficult for me because you can put a ruler. No, let's just do that. Okay, no, I'm going to take, let's just see if I can find a ruler. Pictures, shapes, applications, a ruler. Okay, I have it. Okay, but then I must just move my ruler. Yeah, and I must just make sure, because my yellow line is not cutting so nicely there. Let's just move it a little bit. Okay. Okay, and then I take my blue and I'm just, oh, sorry. And then I'm just going to now let's just get it. Okay. I think my yellow line is not 100% correct, and I just have to, because as soon as I see it's supposed to cut there and there, so I'm just going to see, because this one is correct now. Let's just move this away. Let's just move this away. But this yellow line is supposed to be a little bit lower, and I'm going to just show you. So this is actually a challenging one because okay, going a little bit lower there. Okay, I think it's better to first draw this one. I just need to correct this little space here. Again, my technology is a bit challenging. Okay, so basically, if I was here and it was at -1 and 2, and then this one is, maybe it will be better if I draw it from this side. No. Now I have a straight line instead of a ruler. Okay, so this is actually supposed like it's going to be, because it must cut there at 2 places. But it was a bit challenging because this line was just touching it there. Because now, state the number of solutions. Did you see it again? State the number of solutions, and I just want to show you this is number B. Again, it was my 2 equations. It was y equals a half to the power of x. Oh, I just want to go a little bit down. And y, there it is. And y equals 1 minus x. Y equals 1 minus x. And then if you substitute the 1 in the other one, you get 1 minus x equals a half to the power of x. And then it's 0 equal, let's just get it correct. 0 equals a half to the power of x plus x minus 1. And now we can check just if this is correct, what was standing there. Yes, a half x plus x minus 1. Did you see it there? And they state the number of solutions. And as I said, my graph was a little bit, it was better to first draw this one. And you can even check it on Symbol Lab, as I showed you in previous videos, just to see this too and to see that you are correct. So basically, so therefore, let's just end. So therefore, 2 points of intersection so therefore 2 solutions. Okay, and that's how you do it. Okay, I went to Symbol Lab and I typed in my functions. My 2 functions was y equals a half to the power of x and y equals 1 minus x. And then I got this sketch. But I really had to use these keys because when I was drawing it, it was actually looking like it was only touching one time. And then I really had to enlarge it to see that it was cutting 2 times. So it was a very close call on this sketch. And I personally don't think it's such a good exam question. They will rather give you one that's a bit more distinguished and that you can really see the 2 points. Okay, but there are 2 solutions. And I did it, as I said previously and showed you on the internet, Symbol Lab. I'm going to the program Symbol Lab to see the sketches.